The DuoLift joist support system has been designed by Millboard to make installation significantly easier and to ensure successful outcomes, providing substantial height flexibility within 4 stackable components. DuoLift removes the common problems of having to order varying height pedestals for a single area. The first component of the DuoLift system is the DuoLift joist cradle. This lifts the joist off the substrate from 15 to 60 mil. In the box we have 10 of the cradles, 10 of the adjustment rings and 20 of the key locking tabs. The joist cradles are not assembled in the box, so they need to be assembled. How they're assembled is you line the slot on the top of the cradle with the slot on the adjustment ring, either at the top of the cradle or at the bottom of the cradle. Line it up here and here, and then wind it down or up, depending on the situation. This is made easier to wind up and down by the bits that stick out on the outside of the adjustment ring. Another point which makes the DuoLift unique is the fact that we have 5 mil markings on the side of the cradle, so easier to set your height before putting it down. Another benefit is that a quarter of a turn is 1 mil, so that is 1 mil, 2 mil, 3 mil. The base of the cradle is 114 mil, which is a increased diameter from the industry of 90 mil. This helps spread loading on roof membranes. On the adjustment ring there are 4 shaded areas. The joist should be between the shaded areas as such. Once the joist is in place, the cradle can be got to the right height, and then once it's at the correct height, a key locking tab is put into the cradle with one either side of the joist as shown. Alternatively, on timber or Plasspro joists, the tab can be turned around and a screw inserted through the hole in the tab. The second component of the DuoLift system is the self-leveling joint. This is comprised of a dome and the seat. In each box there's 10 of each of these items. The self-leveling joint adds a further 20 mil on to the height of the DuoLift and also accommodates a slope of 5 degrees. The dome is simply clicked into the bottom of the joist cradle. The self-leveling joint must be used in between the joist cradle and the riser, or the joist cradle and the foot. The diameter of the base of the self-leveling joint is 114 again. The next component is the DuoLift riser. This adds an additional 45 mil onto the height of the DuoLift system, and again as a 114 diameter base. The self-leveling joint is simply lined up with the riser and then turned to click into place. The risers can be used on top of each other, again lined up and then clicked into place. We advise a maximum of 2 risers are used on their own before we go on to the foot. The next component is the DuoLift foot. This adds an additional 45 mil onto the height of the system. This base has a 220 mil diameter, which is increased to help reduce point loading and increase stability when the DuoLift is used on a sloped base. The riser or self-leveling base is again lined up with the foot, and then again it is turned, clicked into place. I know that this is all in line and clicked into place because the lugs are all in line, as can be seen. Although the risers can be used on top of each other, we recommend a maximum of 5 risers are used on top of each other for stability reasons, and this will create an overall height from the substrate to the underside of the joist of 350mm. The last component of the DuoLift system is the DuoLift acoustic separation pad. This is a 250 by 250 by 3mm thick pad and comes in a pack of 10 pads. This pad is used for when joist supports are used on roof membranes to protect the membrane. Some membrane manufacturers say there has to be a sacrificial layer between the joist support and the membrane. The pad also offers an acoustic benefit when used on solid surfaces, and there may be instances where you want to raise the joist off a concrete base, so you can put the pad down and have the joist directly onto it. All of the DuoLift components require a substrate that is solid, stable and structural. For example, a suitable roof terrace or concrete base, not directly onto soil. An overview of typical heights under the joist can be seen on this diagram.